Now, of course, no good rule comes without exceptions. So all the rules I walked you through over the last lectures, of course apply, but there are a couple of exceptions you might want to be aware of. And you see one right here. This is a Python code snippet using the datetime library, which is part of the Python standard library. So it's a built-in module shipping together with Python, which you can use if you need datetime specific functionality. Now I'm calling datetime now here to get the current timestamp of today right at this minute where this code executes. And this gives us a date object, which we then can format to a string with certain formatting rules by using the strftime method here. And as you can clearly tell, these names actually violate what I taught you over the last minutes. Now is a method. As you can tell by the brackets, we are executing it. It's a method, not a property. Hence, it sounds like a property. It's not describing a command, and it's also not returning a boolean, where something like isNow would be acceptable. Instead, it's just now, and not something like getNow or getCurrentTimestamp. No, that's not how it's named now. And since it's a built-in library, you of course can't change it. This was defined by other people, you can't override it. The strftime method here also has a rather strange name. I'm not sure if it sounds like a command because it's pretty hard to tell what this should be. I can tell you that strftime should stand for string from time because it returns a string from a datetime object, but of course this is really not intuitive and therefore in my opinion not really a great name. In addition, even string from time is not really a command, but again more like a property name. Now again, this is built into Python or into a Python core library, so you won't be able to change it. It does not mean that you have to use the same naming in your code though. You should try to follow the rules outlined over the last lectures unless you have a good reason for not doing so. For example, because everyone in your team agrees that you want to follow a different naming convention. And of course, naming conventions can also differ across languages, though even in Python, you typically should not follow the naming you see here on the datetime library, because I would argue it is not super readable. Now is okay, but strftime, it's totally unintuitive. You need to hover over that to understand what it does, and even that might not be enough, so you might need to dive into the official docs to understand what it does. And if you just explore the available methods here with auto-completion, you see these methods don't tell you anything. So it's really not easy to quickly see what you want to call to achieve a certain result. So that just proves my point that naming matters and that good names matter. And I would argue these are not great names. And of course, as I said, there's nothing we can change about it, but we also don't have to copy it into our code. Now, speaking of our code, this code snippet has more to offer than these built-in library method names here. For example, I defined my own class and I named it dateUtil. Now, dateUtil is not too far away from this manager pattern, which I just said a couple of minutes ago that you shouldn't use. You should avoid names like database manager, remember? dateUtil is quite similar, but actually here it's really an exception. Naming classes like this, dateUtil, or also utility to be even more expressive, can make sense, especially if they mostly contain static methods like this one does. A static method, of course, is a method which can be called without instantiating the class first, like we're doing it down there. Then the class simply is there to group related functionality together, and then adding something like util, utility, or even manager in the class name can make sense to signal that this will not be instantiated, but that it's just a grouping of, well, utility or helper methods, like we have it here. So these are some exceptions and things to be aware of. Another exception can be seen in this code snippet, which now is written in TypeScript and therefore JavaScript. Here I have a database class which has a private property client, which is actually set when the connect method is called. However, since that property is private, it can't be accessed from outside the class. For that, we instead have this connected client getter. And getters and setters are special concepts which exist in multiple programming languages to provide you as a developer with greater control over how data in a class can be read or set. For example, a getter allows us to control access to certain properties in the class. In this case, we control whether the client is initialized before we return it. And here you will notice that even though connected client is written like a method, it has brackets and a function body, it actually has a name like a property. It's not getConnectedClient, but instead just connectedClient. Because actually this getter would be accessed like a property. That's just a language feature JavaScript offers, and many other programming languages have similar concepts. So for getters and setters, it is okay to use property naming rules, even though it's technically written as a method. But since we access it as a property, we should also name it as such. So that's another exception to be aware of. However, even with all these exceptions I just showed you, it should become clear and obvious that these rules which I outlined over the last lectures are super important and apply in the vast majority of cases. By now, we had a look at a couple of rules that you should consider when you pick names for your variables, functions, or classes. There also are a couple of pitfalls you should be aware of, a couple of errors which are easy to make. Now here's one thing which I already mentioned, but it's really important. Don't include redundant information in names. User with name and age is pretty bad if you create a user like this, because it's kind of obvious what's in this user, and if we would want to stick with this pattern, we could come up with super long variable names if that user would not just have a name and an age, but maybe also hobbies, a role, a first and a last name, and so on. You get the point. So this is too specific. Yes, names have the purpose of making us understand code without diving into the details of a certain implementation, but that does not mean that we want to describe everything with a variable name. This is too much information which doesn't help us. In most code snippets, it's probably enough to quickly understand that we're storing a user, not that it's a user with name and age. If we want to access that information, modern IDEs and editors will give us auto-completion anyways, and we can also simply expect certain fields to be in that object given the fact that it's named user. It's very likely to have a name after all. Hence, better names here would be just user, or if we want to be more specific because it makes sense, maybe it's a new user, because maybe this code gets executed in some part of our code where we are only operating on a newly created user, and that information might be important. Or maybe it's a logged in user and we want to reflect that, and we want to make sure that everyone reading the code knows that for this user you don't need to check whether he or she is logged in, for example. These could be variations which make sense. User with name and age doesn't make too much sense. Also, avoid slang, unclear abbreviations, and disinformation. You want to avoid slang like this, for example. It might be funny to you, it might make sense to you, maybe also to you and your team, but overall it's not too helpful. And if I dive into this project and I have not been part of the team right from the start, I don't immediately understand what these methods are doing. Die please, for example, sounds like the product is about to be deleted, but I can't be 100% sure about that unless I dive into the code. So instead, don't use slang, use objective, clear names like remove or send error message here. Unclear abbreviations can also be a big issue. Consider these examples here. Message n, and then ymdt equals something. The second line is probably some date snapshot, but it's hard to reason about it. It's not clear what is what, at least not immediately. So here, clearer names help a lot. If we use new user instead of n, it's clear that we're sending a message to a new user and not to something. And if we name the variable date with time zone or something like that, it's also much clearer what's inside of that variable. Last but not least, disinformation should also be avoided. And I have seen code like this. We have all seen code like this. We maybe even wrote code like this. What's the problem here? Well, the first line of code has a variable named userList, but this isn't a list. It's a JavaScript object, or close to a Python dictionary. It's definitely not an array. There are no square brackets. All accounts implies that we have, well, all accounts, but instead it looks like we're filtering for certain accounts. So by definition, we probably don't have all accounts. At least it's misleading. So better names would be user map or just user if we store some object or map in that variable instead of a list. And filtered accounts makes more sense than accounts filter. Of course, depending on the application we're writing, we might also be able to replace filtered accounts with a better name. Maybe it's just the user accounts who have a paid plan. Then we could name it paid accounts, making it clear for what we're filtering. But it's all better than all accounts for sure. Also make sure that you work with distinctive names. Let's say you work with some analytics class which you used to create an analytics object. And now this class exposes a couple of methods to you. Get daily data, and you pass a day into the method. Get day data, get raw daily data with a day argument. Get parsed daily data with a day argument. What are these things doing? Don't write code like this. These methods all sound very familiar. It's very hard to tell what the different methods do and which method you want to use. And therefore, again, if you are the person diving into that code or working with that code, you have to dive into these methods first to understand which method you now need to call or what could be causing a certain bug. So instead use distinctive names, like getDailyReport, if this maybe doesn't return the data, but some PDF or Microsoft Excel report. Get data for today makes more sense than get day data because it's clear that it's the data for today. Get raw daily data makes sense, but now it doesn't clash with the other names because the other names are very clear and distinctive now. So now it's very easy to tell what the different methods do, and therefore working with this code becomes much easier. Now the last pitfall, or the last thing, the last concept to be aware of, is that you should stay consistent when naming things. For example, let's say you are writing a function which retrieves some data, let's say a list of users. You could name that function getUsers, fetchUsers, or retrieveUsers. They all kind of describe the same thing, and all three names would be fine. You can go with either of these options, but then stick with it. Be consistent. Throughout your entire program, always use the same pattern. If you went with getUsers in one place, also use getProducts in another place. And don't have fetchProducts in one class and getUsers in another class. It will not be obvious if these methods do generally the same thing, or if there is a key difference between getting and fetching in your program. So be consistent and stick to the names you go with. If you then decide that you don't like the name, you can always change it, but it will probably not be the get, fetch, or retrieve part which you don't like, but the part thereafter. And that's really it. These are the core rules, the core ideas and concepts, and the core pitfalls and problems you should be aware of and you should consider when naming things. So therefore, let's now dive into a couple of demos and of course also your challenge. So now that we got all the theory out of the way, it's time for some demos and for some bad to good code conversion, which we can do together for the moment. Your challenge will follow. Now you find this file attached, demo01 bad name examples py, holding some Python code, and you can download it. You can also run it if you got Python installed, but that is absolutely not something you need to do. We will only work on the code and try to transform it from bad code, from dirty code, to clean code. Now, what's this program doing? We are defining some class here, a class named entity. It has a constructor function. This is how a constructor function is defined in Python. And this constructor function receives three main parameters. The self keyword is a special keyword and a special parameter in Python, which is basically the same as the this keyword in other programming languages. So we get three parameters which are being stored in properties of this class here. Then we got a function, not a method, but a function. If it would be a method, it would need to be indented differently. It's indented like this, so it's a function outside of the class, which takes an item and which then in the end accesses various properties on that item to simply print their values to the console. Now, the item clearly is an instance of this entity, since we are accessing title, description, and this strange property. Further down below, I then have a couple of variables with various values, which are being passed to the entity constructor to construct our item, which then is passed to this output function we just had a look at. So that's what the code does technically. Now, what is it doing logically? Well, it looks a little bit like entity in reality would be some kind of blog post. Because we have a title, we have a description, and we have something which is a date in the end. It's the date of today formatted as such a string, where we simply start with the year, then the month, then the day, hours, and minutes. So this here, in this example, should be a blog post. Hence, a better name than entity is blog post, describing what this class will be and which kinds of objects we can create with that class. Now, what about the parameters we get there? I think title and description are alright, but what about this YMDHM thing? This in the end is just the encoded version of our timestamp here, but this is of course not really understandable and human readable. In the end, it is just a date, right? So maybe we should name it date. If we knew which kind of date it is, we could also be more specific. For example, if this was the date on which this blog post was published, we could name it date_published, for example, or publish date. Both would be options you could go with here. It always also comes down to your personal preference to a certain extent. So I will name it date published, and I will assume that this is the published date. So then, of course, we need to adjust it here and here as well. I want to use that same name as the property name, and I want to store the value we receive on that parameter in that property. With that, this class doesn't look too bad. It's now way more descriptive already. Now what about output? In the end, this is just outputting the blog post, right? So maybe we should name it output blog post, or I personally prefer print over output. So print blog post makes it way clearer what this function does. And it's really only good at printing blog posts because we try to access blog post properties inside of the function. So a more generic name like just print data or anything like that would kind of be deceiving because it would sound like we can pass any data into this function when it will actually fail on any data which has not the structure of a blog post. Hence, I prefer the print blog post name. We can also rename the argument then and change it from item to post or blog post, whatever you prefer. And then, of course, we also need to use that name inside of this function. Now, this is also more readable, and we can now focus on the code down there. Now, these names here are pretty much all messed up. Summary is at best okay-ish, but this is the title of the blog post. Why don't we just name it title? This would be way clearer. Desk, of course, is an abbreviation. Actually, it is an abbreviation which might be clear, but I personally prefer description. It doesn't leave other developers guessing whether that is a description or maybe some other kind of text. But I think desk would have been acceptable. Nonetheless, description is cleaner, in my opinion. Now what about this date? We are fetching the current date as of today with this code. Whether that makes sense or not is another question, but that's what we're doing here. Now the name new date is okay, It is a new date which we are generating, but maybe now or date today or just today. Anything like that might be better. And I will go with now because it makes it clear that this is the current timestamp as of now, as of right now. Here, publish is a bad name. This sounds like a command, and we definitely don't want to name our variables like commands. Instead, as you learned, variables are data containers, and we want to describe which kind of data is in that data container. Here, it's the formatted date in the end. Now is the date, and we're formatting it here. Of course, here I want to use now, therefore, and here we could have the formatted date as a name. Because this describes what's inside of this variable. It's a date, and it's not just any date, but actually a formatted date, formatted in a certain way. Now down here, we previously used entity, the entity class. This is now the blog post class. So of course here it's blog post, and we pass in the title, the description, and then the formatted date. And it shouldn't be called item, of course. Instead, this is a blog post or just a post, anything like that. It depends on the context. We can go with just post here. Because of the surrounding code, it's clear that it will be a blog post. To be super safe, you could of course always go with blog post here if you wanted to. And then last but not least, here we have print blog post, and we pass the blog post to this function. And this is now a cleaner version of that code. It's definitely not the only way of rewriting that code, and you might come up with names which you personally prefer over the names I showed here, but you will probably agree that this code is now way more readable and meaningful and descriptive and self-explanatory than the code was before. Now this code which we just wrote, this code which we transformed from dirty to cleaner, could actually be improved even more to be even cleaner. Because the problem we have with this code right now is that we do have some redundancy or some aspects to it which I don't totally like. For example, this print blog post function. We have a blog post argument and blog post in the name. This is kind of redundant. But as I explained, just print data on the other hand would be too unspecific, and it would kind of signal that we can pass in any data when that's actually not true. A great way of enhancing this code even more would be to simply turn this function into a method of the blog post class by moving it into the blog post class, which in Python's case is done by indenting it. Now, that being a method of that class, it also needs to receive the self parameter as a first parameter. This is just a Python thing to unlock the self keyword in this method. And now we can operate on the properties of this class, and we don't rely on some input parameter anymore. So we can remove that and instead now simply access self.title, self.description, and here self.datePublished. Actually, that date name was something I forgot to replace in the last example anyways. But now we turned this into a method. And the advantage of this is that now we can simply call blogpost.print, and we can rename this to just print up here instead of print blog post, and then call just blogpost.print. And this is now very expressive and descriptive, I would say. It makes it very clear that we are printing that blog post. So we are outputting data about that blog post. And that's very descriptive and very easy to understand and read. So that's one easy way of improving this code even more. And you might find more ways of improving it. But that was one improvement I wanted to make to also show you that sometimes it's not just about changing a name, but about changing something in code, which then thereafter makes naming automatically easier and more descriptive. And we'll see more of that later in the course once we also dive into functions and classes. But this was a first glimpse at something which sometimes is the best possible solution. Not messing around with the name, but instead moving it somewhere else in code. As we did here, where we turned this from a regular function into a method of the blog post class. Now that we saw many examples, learned about many rules, and saw a complete transformation step by step in action in the last lecture, it's time for your challenge. Time for you to apply what you learned. And for this, attached you find this example code, again written in Python, and again you can execute it, but you don't have to. Instead, you should understand what this code does, and then you should find all the places where you're not happy with a certain name. No matter if it's a class name, if it's a variable name, a function name, a method name, whatever it is. Now I will say right away, not all names in here are bad. There are names which are absolutely fine. You can still, of course, come up with other names if you prefer it, but of course, most importantly, you should focus on the bad names, and you should come up with better alternatives. Once you did that, have a look at my solution video to see which bad names I identified and which better names I came up with, so that you get a feeling for how I tackled and solved this. So in this code, we are working with some geometric objects. We got a point class, we got a rectangle class. At the end of the file, we are calling build stuff, where in the end we are constructing a point and a rectangle, storing both in variables. We then return the rectangle here, hence it's getting stored in my rect. And then I simply print the area of that rectangle, and I call the endpoints method in that rectangle class. That's what the code is doing. And there are a couple of names which are good and a couple of names which are bad. Now, good names would be point and rectangle, for example. I'm happy with these class names. You can always be creative and come up with other names, but I think these names are pretty straightforward and there is no need to change them. If we have a look at this constructor function in the point class, though, there already are names I'm not so happy about. And that would be chord X and chord Y. Now, the thing is, these names are not horrible. You can leave them. They are not bad. But they are also not great, because they do have a bit of redundant information attached to them. If the class is named point, and we do have a X and a Y argument, it's pretty clear what this stands for. It's clear that these are some coordinates, so this coord prefix is really redundant. We could just use X and Y here, instead of chord Y and chord X. There's no reason to keep that around. So I prefer this. And this is a rare case. Here I prefer the shorter version, the abbreviation so to say, of a certain name instead of the longer form. But because X and Y are common knowledge, it's clear that we have X and Y coordinates in a coordinate system, and because it's in a point class, I think these names are super clear and actually more descriptive than the longer names, since it's less to read. Now what about the rectangle? The class name is fine. In the constructor here, again, I'm not too happy with all those names though. We got the starting point and then broad and high. Now, starting point could be okay. This is basically a point in the coordinate system where the rectangle would be drawn, or where the starting point of that drawing would be. It's therefore okay, but I think a better and more concise term could be origin. Now, again, this is up to you. This is not something you have to replace. Starting point would be okay, but I prefer origin because it is a bit more concise. Now, when it comes to broad and high, I'm absolutely not happy with these names. Broad and high, that is basically slang or some strange wording, strange language. It would be more appropriate to use something like width and height here. These are the proper measures which we're used to from other areas as well. Even outside of programming, we talk about widths and heights, not about a couch being broad, for example. So here I want to go with width instead of broad and height instead of high. This is definitely cleaner. Now what about the area here? This is a method in this rectangle, and typically methods should have a name that describes the operation which is performed. And area is not a command. It sounds like a property. Now property-like names could be fine if we would be returning a boolean here, or actually also if this would be a getter, which is a special kind of method. But since neither of the two things is the case here, I prefer getArea here, because that makes it clear that we can call this method to get the area of this rectangle, which is exactly what's happening. Of course, here, by the way, we should also use width and height, since I changed these names up there. Now what about the endpoints? In the end, this method is printing a bunch of information about this rectangle. It's printing the x and y coordinates of the starting point, and then basically it prints where the rectangle ends on the x-axis and where it ends on the y-axis. And we also have these two helper variables here. First of all, of course, we should make sure that we also use width and height down there since we changed that. And here we changed starting point to origin, so we want to replace this in all 4 places as well. And chord x now is just x, chord y is just y, so we also need to adjust these things here. Now about the naming we introduce in this method itself, namely the top right and the bottom left name, which we introduce here and which we then use down there. Are these good names? I would actually say you can go with them. You will definitely also be able to find alternatives, which you personally might prefer, but these names are pretty descriptive. It's clear that this is the top right corner of the rectangle and that this is the bottom left corner. We could name it top right corner X or something like this, but this would actually be a bit redundant, since the top right corner naturally only differs in the x value from the origin. On the y-axis, it's on the same level as the starting point, so the x-axis, the x value is the only point which will be different. For this, of course, you have to keep in mind that coordinate systems in programming typically start in the top left corner. And with that, it makes perfect sense to name this top right to indicate that this is the x value where the rectangle ends. But again, you definitely also can find alternatives here, which also could be fine. However, I will stick to these names and therefore leave this method as it is. Now for the rest of this code file. Here we got the buildStuff function. And as you can imagine, buildStuff is not a great name. This is slang and it's totally not clear what it's doing unless we look into it. A better name here would be buildRectangle, because this is what this function does in the end. It constructs a new rectangle by first of all building the origin point and then building the rectangle itself and then returning it. So buildRectangle is a better name and should also be used down there. Now main point is also kind of a bad name. It's not clear that this will simply be the origin of the rectangle. So a better name might be rectangle origin, because that is what we plan to do with that point. It should be the origin of the rectangle. So let's name it as such and then use it down there. Rect is an abbreviation, arguably one which is clear, and still there is little that speaks against simply calling this rectangle. With that, I'm happy with the function and we can move down to the last lines. MyRect, of course, is a horrible name. I mean, what should this be? Is it the developer's rectangle? The rectangle of the user running this code? It doesn't make any sense. This should just be rectangle, or if you had some other more specific version, like user rectangle, then of course you should use that name. But don't use MyRectangle or anything like that. Also not the rectangle. What would that be? Instead, in this case, I'll just go with rectangle, and then of course call rectangle getArea here, since we renamed this method, and rectangle endpoints down there. And actually, this brings me back to this method. One thing I forgot. Endpoints is a name you could keep, but we actually are not just printing the endpoints of this rectangle, but also the starting point coordinates. So actually, I personally think that a name like print coordinates is way better. It also makes it clear that we're printing something, which endpoints doesn't make clear at all. It does not indicate what's happening. It's already a bad name because it's clearly not describing a command. It sounds like a property. So print coordinates is way better. It makes it clear that this method will simply print all the key coordinates of this rectangle. Hence, this is the name I'll go with here, and this is now the name I'll use down there. And one other error I spotted here, which I of course also want to fix. Here I have self-height y. This of course is wrong. This should be self-origin y, and self-origin x down there, and self-origin y down there. I had a copy and paste error there. So now with that, this is the finished code, and we could now also execute it, which again you don't have to do. But if we do that, we get the area of this rectangle, and we then get the key coordinates. Hence, this is now the challenge solved. And of course, you will pretty much certainly have different names than I do. This does not mean that your names are wrong. I just walked you through my names and most importantly, for the reasons why I chose those names. If those reasons also apply for your names, if your names also meet the requirements and fulfill the rules outlined in this section, they are, of course, also fine. Ultimately, there will never be just one single correct name for something. There just are a couple of bad names, as you learned in this section. In the last course section, we learned how proper naming can help us with the code readability and therefore with the maintainability of code. In this course section, we're going to dive into things we can do beyond naming things to improve readability or to hurt it, as you will learn, because this section is about comments and code formatting. And it turns out that both can be used to improve our code or to make it worse. Therefore, we'll learn that comments are mostly bad, but I will also explain which kind of comments would be good. We will learn that code formatting is important and how to format our code, also how to adhere to language conventions. And of course, again, we'll have examples, demos, and a challenge for you so that you again are able to apply all these concepts not just in theory, but also in your own projects. So what can we say about comments? Well, just one main thing. Typically, you want to avoid them. Of course, there are a couple of exceptions though. But indeed, a lot of comments are just bad. For example, because they simply convey redundant information. Have a look at this code snippet. The comments you see here are pretty much redundant. For example, this comment, the database engine to which we want to connect. Well, if that's what we have here, why don't we just name it DB engine and use that name in our code instead of DB driver? Also, these comments here. Connect to the SQL driver if driver is set to SQL. Well, this should be obvious. If you use proper names, as we now do in this example, you shouldn't need any explanatory comments because the names should be self-explanatory already. And this code reads just fine without comments. Actually, the comments even make it a bit harder to understand it because there is extra text to read. And you will probably not skip this text if you go through the code because it might contain important information. So here you have a great example where comments actually make it harder to understand the code. Another kind of bad comments would be dividers or comments that simply mark a block of code. Again, here's an example from the same file. I got these big markers here, which basically just inform the developer going through this code file that we're defining a couple of globals and then a couple of classes. Well, again, this should be obvious. I mean, we don't have to tell anyone that we're defining a couple of classes. We can tell by the class keyword. So comments like this also should be redundant. And if you feel the need for introducing them, then you might simply have too much code in one file, and you might want to consider splitting your code across multiple files instead. Amongst the worst kinds of comments are misleading comments. For example, consider this comment here. We say that we're updating a user, but actually the name implies that we're inserting a user, which is not the same as updating. So what are we doing? What the comment says or what the name says? So all of a sudden a name which was good now is a name we have to question, and we have to dive into the insert method to see what it really does. So that's a great example where a comment does not help us at all. If the insert method would really be updating a user, we of course should rename it. And if we can't rename it because it's from some badly written third-party library or for whatever reason, then we should at least update the comment to be something like this, where it now really makes it clear that the comment is right and not the method. Of course, we should still rename the method as soon as possible though. Now, another practice which you see quite often is commented out code. And I will say, I myself do comment out code, for example in some of my other courses, to keep it around for reference or to, well, keep it in sight whilst we maybe replace it with new code. I'm fine with doing that, but you shouldn't permanently comment out code. If you really have code which you don't need anymore, you should just remove it. Nowadays, we should be using version control systems like Git anyways, and therefore we can always bring back deleted code if we really need it. So don't be afraid of deleting code, just do it if you don't need it anymore. So instead of keeping around code like this, we should just delete it and then simply commit this change. And assuming that we also committed changes before we deleted it, we can always go back to these older states if we need that code again. Now, as you saw, many comments are bad, but actually there also are acceptable or good comments out there. For example, one kind of comment you will see in some code files would be legal information. Again, this example code file from before, which contains many bad comments, it also does have such a legal disclaimer or such a legal comment right at the top. And depending on the kind of project you're working on, you might be required to add something like this to every code file you write. Of course, if it's your own project, you can decide this on your own if you need that or not, but in a lot of organizations, you might be required to add something like this. And then of course it's absolutely fine to do so. I mean, you don't really have an alternative to that anyways. It doesn't really hurt the code readability though, because it sits right at the top of the file. It's clear that it contains legal information, and therefore it can easily be skipped and ignored. Now, another kind of comment which is actually good is a comment that adds an explanation which can't be delivered or replaced by proper naming. And this would be an example. We're using a regular expression, and even though that's a relatively simple one, regular expressions can get quite long. And having a little comment next to it which simply explains what this regular expression does or checks for can be worth a lot. Another kind of comment which could make sense would be a comment that warns you of something. For example, here we have a comment warning us that this specific API, the local storage API, is only available in JavaScript running in the browser, not running on another machine with Node.js, for example. Now, we can always argue whether we really need this comment. I mean, after all, you could expect fellow developers to be aware of that, or you might want to place it in a try-catch block or some if statement anyways. But if you have neither of that, for some good reason, then adding a warning like that could make sense. Now, last but not least, a comment which is also okay to have would be a to-do note. You see one here. Even though that file had a lot of bad comments, this is not one of the bad comments. This to-do note can make sense. Now, of course, we could argue whether we should have an empty method where everything is missing, and if it wouldn't be better to just remove it and then add it all in one go. But if you do have some code which is unfinished, adding a note like this can indeed make sense and can be okay. Of course, you shouldn't overdo it though, and instead you should focus on writing code which you finish instead of leaving unfinished code sitting around in your code base. Now, one last kind of comment which can make sense is a comment where you add documentation, especially when providing a public API. So methods, properties, classes, which can be used by other people, not just in your organization, but maybe also from all around the world. If you're building a library which you want to share as a third-party library with other people. Then adding documentation strings, which can be picked up by IDEs, for example, of course also makes sense. And here it then really comes down to the programming language you're using. For example, for Python, you have a certain structure for how such documentation strings should look, and other programming languages might bring their own conventions. So documentation comments are a special kind of comment which can make sense depending on which kind of project you are working on. And that is already it for comments. Hence, the general rule really is that you should avoid comments with the few exceptions I showed you over the last minutes. Now, where comments can rarely help and often hurt our code, code formatting is another thing which is really helpful when it comes to improving the readability and understandability of our code. Because code formatting improves readability and helps us transport meaning across our code. And we can differentiate between two kinds of code formatting: vertical formatting and horizontal formatting. Vertical formatting simply refers to any formatting, any code structuring we do from the top to the bottom of our file, so vertically. That includes spacing between lines and grouping of code. And I will show you concrete examples in just a second. Horizontal formatting, on the other hand, is everything which happens within one line of code, so horizontally. And that involves indentation, space between code in one line of code, and of course in general the width of our code lines. Now when it comes to formatting and formatting properly, it is of course true that formatting is important and helps us with code readability, but only if it's done properly. And here we'll not just have some general rules and concepts which I will show you over the next lectures, but we'll also have language-specific formatting rules, where most of the concepts shown in this course apply across all languages. We also have formatting rules which differ between different programming languages. And it's always the general conventions and style guides of these languages which you want to follow when it comes to formatting. So for example, if you think about indentation, something I will come back to in a second, and you think about whether you want to indent by 2 spaces or 4 spaces or by using tabs, then it's always also the language guidelines and style guides which you will typically find, which answer the question on how to indent properly. So you never want to forget about these. Nonetheless, there also are some general rules and concepts which always apply. And these are the rules and concepts we're now going to have a closer look at. So let's now take a closer look at these two kinds of formattings, and let's understand which kind of rules we should follow there. Now let's start with vertical formatting. Vertical formatting is about using the vertical space in our code file. And there we have one simple rule. Your code should be readable like an essay, top to bottom, without too many jumps. And this is something you already heard in the first course section. Your code should be nice to read, almost like an essay. And if you read a book, you also don't want to jump from page 1 to page 3 and from the start of page 3 to the end of page 3 before you continue in the middle of page 3, right? You want to have one smooth reading flow. And we want to have the same for the code we write. Now, to achieve this smooth reading flow for our code, there are a couple of rules and concepts we can keep in mind and follow. For example, if your file becomes too big, if it houses too many different concepts, you want to consider splitting it across multiple files. Now, there is no hard rule on how many lines of code in one file are considered to be too big. But in general, whenever you have a file with a lot of different concepts, for example, multiple classes being defined in one file, then it is probably too big and you should split your file into multiple files. For example, as a rule of thumb, if you are working with classes, it is a good rule that you should have one class per file, not more than that. And this will help with keeping your files short and therefore readable. Now, within one and the same file, you will still have multiple different concepts. And with concepts here, I don't mean different classes or anything like that, but for example, simply multiple methods within one and the same class. That could be different concepts, different areas of code, you could say, and you should separate those concepts by spacing. And here's an example. We start by importing from a third-party package, or in this case actually from the Node.js core library. So in this case, some core functionalities which are built into Node.js, which is a JavaScript runtime. I'm importing these functionalities, and then I'm defining a class. The disk storage class, which has a constructor, and then various methods for creating directories and for inserting files. Also for handling the completion of our operations and for handling errors. And then at the very bottom, I instantiate this class twice to have different storages, different folders, and then I insert different files into these storages. Now what you will notice is that I have some blank lines in this code file. And in general, throughout all the examples I showed you up to this point, I do have blank lines. And you should have blank lines, because these blank lines create vertical space. And this space makes the code more readable. Consider this alternative version of this file. It's the exact same code, but I did remove all the blank lines. All of a sudden, it's way harder to read. It's way harder to tell what belongs together and what doesn't. It's way harder to tell where a method starts and where it ends. Even though I did not remove indentation or anything like that, it's just the blank lines which are gone. And this shows us how important and helpful vertical space is. So you should introduce blank lines and therefore vertical space between different blocks of code, different areas of code. For example, here I start with my imports, then I have a blank line before I start with the class definition. Then we can add one between the class definition and the constructor. We definitely should add one between the constructor and the next method, and between all other methods, to make it clear that these are different methods and that it's not one huge method. Once the class definition is done, I add a blank line here before I start using the class, then one after that before I start using the instantiated classes in that new timer which I set here, and then I have no blank lines between all these lines because I'm doing the same thing just on different storages. So that is closely related and the same kind of action. Now obviously you should structure the code in a way that makes sense to you, but adding vertical spacing is definitely something you should do. So different concepts should be separated. Similar concepts, on the other hand, should not be separated by spacing. And that's what you, for example, saw in these or in these lines here, where I basically have the same kind of operation. I instantiate my disk storage, or then I insert files, and hence there is no real reason for a separation. It's the same kind of task, the same kind of thing which is being done there, hence I keep that close to each other. Now, last but not least, we also should keep related concepts close to each other. At least we should consider doing this. And indeed, if you have a look at this demo file, you will see that in the constructor, I call the setup storage directory method, and it is the very next method in line. In there, I call the create storage directory method then, and that is the next method in line. Now here I point at the handle operation completion method, and it's not the next method in line, instead it is down there, but simply because in between I have another method which will also point at this handle operation completion. However, in handle operation completion, I then point at handle file system error, and that is a method which is right below handle operation completion. So I'm keeping these related methods, or these methods which are calling each other, close to each other, at least in the places where this is possible. Technically, we could also take this insert file with data code and remove it from here, and for example add it here, between setup storage directory and create storage directory. Everything would work, the code would not break, but it would be harder to read. If we go through this file, we see that we're calling some create storage directory method here, but we don't see that method immediately. Hence, we have to scroll through the entire file and search for it. Obviously, this is a small class, so it's okay, but still, it's unnecessary work. It doesn't read smoothly. We have a jump in our file. And as I explained a couple of minutes ago, we want to avoid such jumps. After all, when we read a book, we also don't have such jumps. Hence, the better place for insert file with data is not between two methods which are closely related, but somewhere else, where it's not directly between related methods. Now, with the concept of keeping related concepts close to each other, we already touched on ordering. And ordering, of course, also is important when it comes to formatting your code. Now, the rules on how to order things in a class and outside of a class always also depend on the programming language you're using. For example, if you have a language which knows the concept of public and private properties and methods, there often are rules on what should come first. For example, that you start with the public properties, then you have the private properties, and then you continue with the public methods followed by the private methods, or the other way around. So when it comes to this specific ordering, it is the style guides of a language you might want to consult. But besides that, the concepts explained throughout the last lectures apply nonetheless, no matter which programming language you are using.